I want to step back. You've had tutorials, you've done some homework and things on how to solve logarithmic problems, how to solve for variables and exponents and things. But I wanted to step back here for a second and say, okay, how can you practically do this? How can you think through this without really actually doing the math? One of the things that comes up on national exams all the time, so a lot of times things will be in base 10. For example, a radiation shielding problem, we may want to know, how many 10th value layers will it take to reduce a radiation field of 32 R per hour to, let's say, 10 MR per hour. And the definition of a 10th value layer, and we normally abbreviate TVL, and that's the thickness required to reduce the radiation field to 1/10 of its original value. Okay, here's where English gets important, folks. 2. Okay, we're reducing it to 1/10, not we're reducing it by 1/10 or anything. We're reducing it to 1/10 of our normal value. So we're not going down to 90%, we're going down to 10% of its original value. And so I'm just going to give you a problem, say, for a certain radiation energy, for a certain shielding or whatever, we're going to just say that for this condition, 1 TVL is equal to 2 inches. And we want to know, well, how many inches are we going to need here practically to bring this from 32 R per hour down to 10 MR per hour? And in past lessons, you would have said, oh, okay, well, I final is equal to I initial, and we would want to solve how many 10th value layers would it take, n would be the number of 10th value layers, would it take to reduce that. You would have put in here 10 MR per hour, and your I initial, which is 32 R per hour, would actually be 32,000, right, millirankin per hour. Doing our unit conversion, 1/10 n, and we would have solved for n. We would have used logarithms. We would have used the base 10 logarithm to figure this all out. But folks, we can stand back from this problem and think about this, because we're talking really about a base 10 here. Well, what you can do is you can just write out 32 R per hour is 32,000 millirankin per hour, and we need to reduce that down to 10 millirankin per hour. And every time we put 2 inches of lead, we reduce this thing by a factor of 10. That's what a 10th value layer, see, the thickness required to reduce the radiation field to 1/10. So what we can do is we can start, here's our decimal place on 32,000, and say, what do we take the decimal place once? And we put in 1/10 value layer, it's going to reduce it by 10. We'd be down to 3,200 MR per hour. So that would be 1 TVL. So we can just put tally marks. Whoop, there's 1. What if we put on another one? We actually have a couple of them. Well, then that's 2 TVLs. We put 2 thicknesses, and we're down to 320 MR per hour. Are we at our 10 MR per hour yet? No. Okay, let's reduce it again down here. Another one. Okay, so now we put 3 thicknesses here, and we're down to 32 MR per hour. Are we down to 10 MR per hour? No. Well, let's put 1 more, and now we're down to 3.2 MR per hour, and we'd be less than the 10 MR per hour. And you say, well, that didn't really solve for it, Bruce. Well, yes and no, it didn't. We know that the amount of shielding we need is somewhere between 3 pieces of shielding that's 2 inches thick and 4. we need somewhere between 6 inches, right, to 8 inches of lead there. And that might be a good enough estimation for us to practically do the job. It definitely will help you on national exams, because a lot of times national exams will be a multiple choice exam and they give you A, B, C, or D. And they might tell you in this, they might say A is, 2 inches and B is, 4.5 inches, and C may be, 5.2 inches, and D may be, 7.4 inches or whatever. And I don't know what this exactly comes out to be, but let's say that if you did the whole logarithm thing over here, you get exactly 7.4 inches. But notice here that if we know it's between 3 and 4 of these 2 inches, it's between 6 and 8 inches. You could have just went 1, 2, 3. Oh, I need between 3 and 4 layers. I need between 6 and 8 inches. And you look down here and say, look, the only one that makes sense is delta. And that's a lot faster than sitting here and doing all the math. Okay, so this estimating thing is very important. So if you got a base 10, you can do that. If you got base 2, a lot of you can either divide by 2 in your head, divide by 2 and count how many times, or you can actually do divide by 2 on your calculator. I kid you not, I had a graduate. Guy was just about ready to finish my program, and he really had forgotten how to take logarithms and solve this properly, and there was